One of the problems in machine learning is the randomness of the entire operation. Why the randomness? Because the data that's used to train the systems, the data that's used to infer the results, is naturally random. Hence the randomness of the outputs. But in some models, like XGBoost, the randomness also seeps in through the initial conditions. The random seeds of the algorithms, every time you run them, even though you may have exactly the same data, produces different results. This means that the error surfaces when you're training, when you're doing the hyperparameter searches, are fuzzy. It is difficult to characterize them. So the real importance of all the elements of the problem are obscured, and this makes it expensive to search for the hyperparameters and expensive to train, because what the system is seeing when it's searching for the hyperparameters, for the parameters, it's not very clear, because every time it runs the problem and changes the random seeds, gets different results. So what happens, for example, specifically in a forecasting problem with XGBoost, when you're using SigOpt? The following. There you have, this is captured from SigOpt's interface. You have 1,000 observations of a very simple forecasting problem running XGBoost. And you see that the system finally finds the right hyperparameters on the order of the 600th. The observation number 600, which is a lot. It's a good number though, below 7.9 in this case. But look at what happens here. The parameter importance. When you're driving a car on a windy road, the problem is fixed by the windy road. It shouldn't be fixed by the car. For example, if you have a very dark windshield, so you cannot see the road, that's a problem posed by the car. It's an artificial problem. The problem should be only the road. What you're seeing in the case of XGBoost, all the parameters there, save for the one enclosed by the red box, are internal to the XGBoost model. By the end shift is the one that in this case is saying how much data, past data, has to be watched in order to produce an accurate forecast. So this is like the only data, the only parameter taking care on how far should we see in this windy road is the end shift. All the other parameters are internal to the problem. It's like the car being the problem. And SigOpt rightly identifies that finding the internal parameters and the correct combination of internal parameters for XGBoost is the problem, not end shift.